Okay, so solving logarithmic equations. Again, here's our list of rules: fundamental properties, special points in the log curve, inverse identities, quadratic condition rule, quotient subtraction rule, power coefficient rule, and change of base property, which isn't used that much. So we talked about how to solve exponential equations in the previous lecture. Now we'll talk a little bit about logarithmic equations. Here's an equation. Can we solve this for x? And it's actually much easier than it looks like. It's just condensing the right-hand side. So how do we condense something? Start with the powers. 2 comes in on the 5. 1/2 comes in on the 16. No power for this, so it just sits as it is. Log base b of x is, well, 25 plus square root of 16 is 4 minus log base b of 10. Log base b of x. Combine these two by multiplying. 25 times 4 is 100 minus log base b of 10. So log base b of x. Now we can combine these by dividing. Is log base b of 100 divided by 10, which is log base b of 10. Great. So what do we get? Same base. So the things inside the logarithm must be the same. So x equals 10. So that's not too bad because the x is on the left-hand side. It's in the logarithm. You just condense the right-hand side and see what you get inside the logarithm. This one's a little bit trickier. Log of x plus 1 minus log of x minus 2 equals 2. We can do a little bit of work here. We have that. Subtraction, you put the second thing into the denominator. We can use the fundamental rule here again, right? Because the fundamental rule says that if we have logarithm of something equals something, we can turn that into this. Base to the power, this is the power, equals the number. So base here is 10, right? If you say logarithm without writing base, is 10. So 10 to the 2 equals whatever's inside the logarithm. Now that's not too hard to solve. 100 is x plus 1 over x minus 2. I'll multiply both sides by x minus 2. That cancel these out. And I have 100x minus 200 equals x plus 1. Subtract an x from both sides. That leaves me with 99x on the left side. Add a 200 to both sides. That gives me a 201 on the right side. So x is 201 over 99. So that's not too bad. Here's another one. Solve this. Log base 2 of x plus log base 2 of x plus 2 equals 3. Again, a plus, that means we can turn this into a product. So log base 2 of x plus log base 2 of x plus 2 equals 3 can become log base 2 of x times the quantity x plus 2 equals 3. And because this is now in log equals something, we can use the fundamental rule again. The thing inside the logarithm is the base raised to the power. So x times x plus 2 equals 8. This is a quadratic equation. X squared plus 2x equals 8. Subtract 8 from both sides, and you're left with x squared plus 2x minus 8. And that factors x plus 4, x minus 2. So we have two solutions, x equals minus 4 and x equals 2. But, and another big giant warning, no negatives in logs, right? The domain of logarithm is only positive numbers. You cannot put a negative number into a logarithm. If we tried to plug the minus 4 back into the original equation, you get log of minus 4 plus log of minus 2. And you can't have a negative inside of that. So you have to throw that one away, and your only solution is this. Right? Remember, no negatives in logarithms. Okay? So, and we'll probably run into the same problem here, right? So we can pull this together. Log base 3 of x times 6x plus 7, quantity equals 1. We can use the fundamental rule again. The thing inside the logarithm equals 3 raised to the power. So that's not too bad. 6x squared plus 7x equals 3. 6x squared plus 7x minus 3 equals 0. We have a quadratic equation that is not that easy to factor. So rather than trying to figure out if I can factor it or not, I'm just going to use the quadratic formula. A equals 6, B equals 7, C equals minus 3, x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's my quadratic formula. Plugging everything in, we get x equals negative 7 plus or minus the square root of b squared. B squared is 49. 4ac minus 4ac, I'll just do a little side calculation here. That's going to be minus 4 times 6 times, that's a, times minus 3. So the minus signs will cancel out. We'll end up with a plus. 3 times 4 is 12. 12 times 6 is 72. So that's actually plus 72. So my number is that. And then 2a, a is 6, so it's all over 12. So we have that. So x equals minus 7 plus or minus the square root of 121 all over 12. X is minus 7 plus or minus the square root, x equals minus 7 plus or minus 11, which is the square root of 121 all over 12. So you have two options for x. One is the plus, one is the minus. Minus 7 plus 11 is 4 over 12, which is 1/3. Minus 7 minus 11 is minus 18 over 12, which is minus 3/2. No negs in logs. So we have to throw that one away. And the only solution we get is x equals 1/3. Okay. So again, these kinds of problems, right? Combine them into one logarithm, and then you can use the fundamental rule, and that will give you, in this case, a quadratic, usually a quadratic. The previous example here, with the subtraction, we got a fraction, and you had to multiply across, and we didn't get a quadratic at all. So that's how you can solve exponential equations.